Today I'm talking about the history of supercomputer Fugaku development. So I'm the project leader of Flagship 2020. And wait on. Flagship Fugaku is one of the outcomes of Flagship 2020 project that's run by Ministry of Education, Culture, Sports, Science, Technology. It's called MEX. That's starting in 2014. And it consists of the two missions. The one is to build Japanese national flagship supercomputer, and that's the Fugaku. And at that time, when the project started, so the Fugaku was unnamed, and so that's why we call it post K instead of Fugaku, of course. And this development is done by RIKEN with Fujitsu. And the second mission is to develop a wide range of HPC applications running on post K. So in order to solve social and science issues in Japan. And so that's the defined in by the MEX. And so in the right hand side picture shows those issues. So there are the 9 issues, and those issues are categorized by 1, 2, 3, 4, 5 the categories. And so okay. So sorry for this. The picture is written in Japanese, but this is the material submitted to the Council for Science, Technology, and Innovation. And so this picture says the target peak performance is about 100 is about the exascale, 1 exaflops, and its effective performance is 100 times faster than K computer with 30 to 40 megawatt. So that was the original the development goal. So let me explain the overview of history. And so the development of Fugaku can be traced back to 2010. That's 4 years before the start of the project. And the original work, this roadmap study, the original work began kind of the grassroots. And so the University of Tokyo, University of Tsukuba, Tokyo Institute of Technology, and Kyoto University, those original organizers, they held a workshop on strategic direction development of high-performance computers. And so it provided an opportunity for young researchers and developers of applications, system software, and hardware to gather together for discussions. And we discuss future systems from individual perspective, not from organizational representatives. And subsequently, the working group on the study of future HPC technology was organized by MEX. And so we have summarized the application. So those applications should be realized in 2020s. and the future supercomputers for enabling those applications. So there are two white papers, roadmap for computational science research, and the other one is roadmap for HPC technologies. Sorry, but so those are the white papers were written in Japanese. And then a feasibility study of the advanced high performance computing started from 2012. And there were the 4 studies run by Tohoku University, University of Tsukuba, and University of Tokyo. University of Tohoku University so their approach was from the vector machine and based on NEC supercomputer. And the University of Tsukuba, so they collaborated with Hitachi to study the accelerator-based supercomputer. And the University of Tokyo, at that time, I was a professor at the University of Tokyo, and I led this feasibility study with Fujitsu, and that's from the general purpose architecture, especially actually the approach from the Spark architecture. And in addition of those 3 architectural feasibility studies, the application feasibility studies also run, and it's led by RIKEN with application developers. And they identify the application for social issues, science and social issues to be solved in the future. And so during the feasibility was going, but the RIKEN, watched those activities and interviewed, and then the RIKEN proposed a system that consists of general purpose CPU and accelerator. That means based on the University of Tokyo's activity and the University of Tsukuba's activity. And so in this the picture, so this was the straw man of post K, and so each node consists of the accelerator. It's a assuming the engines, and it's a and with the general purpose processor. Okay. And so at this time, so RIKEN proposed the peak, the FP performance were about 1 exaflops, and the effective application performance is 100 times higher than that of the computer by co-design. And so that proposal was confirmed, and so the project officially started from 2014. And the first step was we call it the basic design phase. And so we summarize the requirements of hardware and software, and we decided basic architecture and hardware configuration. And also the target of the performance were estimated, and those activities were done by the co-design. I mean the co-design with the computer scientists and computational scientists. And so at that time, so we RIKEN asked the application developers to give us the application codes And so we call them the target applications. And so right-hand side table shows those target applications. And at the same time, so RIKEN examined development and production costs precisely. That's because they are at the 2013, the estimations were very rough sketch, and so RIKEN started to examine. And then we report the result to the next feasibility study on future HPC system. And the result of the assessment said, so those accelerator was sufficient feasibility for the technology itself, but the estimated costs of the development production was so high, and applicability to wide range applications is so limited. So mainly due to the limited budget, so we gave up to equip accelerator unit. And so this slide shows the new architecture, and so this is the origin of the Fugaku in the left-hand side. And but so because we removed the accelerator, so that means the peak performance would be the lower. And but still, we said we promised an effective application performance will be 100 times higher than that of a computer by co-design. Okay. This happened in 2014. And actually, during the feasibility study at the University of Tokyo with Fujitsu, there were the 8 types of the architectures they considered and evaluated. And one of them actually would be reaching the 1 exaflops machine. But the CPU architecture, it's good for Limpak benchmark, but not good for the other applications. And so that's why we didn't take that architecture. And the second, the turning point happened in the 2016. Sorry, during the 2016, and that's in the design and implementation phase. And the project was planned based on technology trends in 2012. That's 9 years before, and so that means the target CPU performance and power consumption were decided using the 10 nanometer device technology that would be available in before the 2018. But actually, in 2015 to 2016, the technological development of semiconductor manufacturers around the world had slowed down, and so we realized that the 10 nanometer technology couldn't be used for HPC the workload, and we must review the plan. And there were 2 alternatives at that time. So resetting the goal and using the 16 nanometer technology at that time. So we could use the 16 nanometer technology by 2018. And but so using that technology, the peak performance would be lower. And so that's why we in this case, we must change the peak performance and several things. And another alternative is to delay development. And we wait for the next technology, that's a 7 nanometer technology. And so after the several discussions, we decided we delayed development will be delayed and using 7 nanometer technology. And at the same time, actually, so we must include some additional values, and so we decided to include the half relation floating point arithmetic for our AI workload, and also because of the 1 year delay, we could use the latest memory technology, that's HBM2. Okay. And so after that, the almost the development is smoothly doing, and then we got the prototype system in 2018 summer, and so then 2019 at the end of the 2019, the hardware was delivered to Kobe RIKEN R-CCS. And so this is a slide of the conclusion. So we face the difficulty of setting goals based on prediction of device technology progress. That's before 10 years before. And we must review the plan, and we decided to delay the development. But fortunately, we could implement a half-recipients FP that's used for AI workload. And so also the expected delay would be 1 to 2 years. That's behind of the original development plan, fiscal year 2020. But so we could provide a machine for COVID-19 issues in the last spring. And also the public operation will start from the next March. And so that is still fiscal year 2020. That means so we also meet the name of Flagship 2020. 2020 means fiscal year 2020. Okay. That's all of my presentation. Thank you for your attention.